Today I want to go over some of the charging trends I've noticed with my HTC 10 Balfon Quick Charge 3.0 using the stock HTC charger, and Quick Charge 3.0 using a 18 watt Tron Smart Quick Charge 3.0 charger, and Quick Charge 2.0 using 18 watt Quick Charge 2.0 Tron Smart charger. So first of all, I want to say that I recorded all this data using two different methods. The first one is a USB inline power meter, power monitor, and another app that would record that data and send over to here via Bluetooth into a log file, and export it here, and manipulate the data. Data points for that were recorded every 0.36 seconds, that's why you see so many over here. And then I also used an app to record my battery millivolts here, temperature, battery percent, all that fun stuff, using Battery Monitor Widget Pro, which records some pretty good data, but doesn't get everything going into the phone like the inline USB power monitor would. So first of all, I'm going to say there are a lot of data points here, probably in the order of, if Excel wants to not freeze, I'd say 20,000 for this particular data set if we want to go all the way to the bottom. So there's a lot of data points here, especially for the voltages and all that fun stuff. I apologize in advance, Excel on my computer can be a little iffy because it's running the preview windows and it's special. Okay, this one has about 15,000 data points here. So there's a lot of data points here for the voltage and the current being tested, which is important because you want to make sure the data is accurate, or as accurate as it can be. Anyway, so here I'm going to show you the base graph of Quick Charge 3.0 using the stock charger. This blue line will always indicate the voltage going into the phone, or the battery millivolts, which you'll see down below, and this one represents your current in amps. So as you can see, there are little fluctuations in the data, which is not a big deal because that happens. But what's interesting here is that the phone starts charging at roughly a little over 7 volts, steps up, goes down, steps up, goes down, which is, indicative of Quick Charge 3.0 because it can take those steps in smaller intervals. However, if you look at the current, it looks like, you're getting, you can just ignore all the little ups and downs and kind of think of it as a straight line the best you can in these small sections. So you have here, you're getting about a little over 2 amps. Here you go up to about, I don't know, 2.4, 2.361. Goes back down, then it goes up, then down, and then down a lot, then up, and then it declines. What's important to look at here is the temperature, which is a measure of efficiency, because if there's more heat being lost or heat going into the battery, you have to think, hey, am I losing all that energy instead of it going into my phone, because this phone gets quite hot while quick charging. So I'm going to first go on this graph. As always, orange is always current. The gray line here represents your battery percentage, which is on the left-hand side, as well as temperature, because those both go 0 to 100. Right-hand side will be your current in amps. So here you can see the battery's temperature initially as you get that spike in current will go up, and you'll get upwards of 106, 107 degrees. Looks like 108 degrees here, 107.96. And then it'll kind of decline as the current declines, and it'll go back up, and it'll kind of sit here at this high temperature until you're at about, that was 86% of your battery in about 57 minutes. So your phone is getting quite hot during this quick charge cycle, which is interesting because, as I'll show later on, my S7 Edge doesn't nearly get as hot while quick charging. So it could be the way HTC designed their phone, I'm not entirely sure. But as you can see here, as you hit 100%, you're still pulling current. You're pulling, 0.27 amps while you're at 100% battery, which I don't know why. This was reproduced on Quick Charge 3.0, Quick Charge 2.0 across my S7 Edge and my HTC 10. It seems that when phones say they're at 100%, they really aren't at 100% battery because they're still pulling current. And it wouldn't record any current being pulled if none was being pulled, because I can plug my USB inline power meter into the wall, and if nothing's being pulled, it will show 0. I can show you guys that in another video as well if you'd like to see. But it's just interesting to me that these phones will continue to charge for a significant amount of time after they reach 100%. So you can see here, this is only roughly 12 minutes. I can show you a larger time lapse where it still pulls current for over an hour afterwards, and it continues, and I just unplugged it because I wasn't going to let it sit there and record forever. So here I have the same graph as you see above, except we're just specifically looking at voltage versus your battery percentage and your temperature. So you can see here with this high voltage, you're looking at roughly 7.5 volts. you're getting that initial spike in temperature, and then it kind of declines as your voltage drops down to just below 5, and then it kind of steps. You can kind of ignore this. You can consider it as like a bad data point. You do get a lot of little ones that go up and down, as I mentioned, which is not a big deal. It's common in any data set. But the interesting thing is watching it step up. The temperature declined a little bit. The second it declined, it stepped right back up a little higher, and then eventually a lot higher until you get to a certain battery percentage, and then it starts to decline. But overall, the voltage is relatively stable compared to some of the other charging methods I've seen, especially Quick Charge 3.0 using the stock charger. So as I go down, I'm going to show you a third graph. This blue line, as I mentioned, it will represent voltage, or in this case, battery millivolts. So you can see here, it's relatively stable as we go throughout this charging cycle, which is a good thing. I mean, it's not oscillating a lot like some other phones I've seen, but it's good to see, all these different figures and what they show, because it's important to look at each facet or each aspect of the battery charging in the phone itself. So this green line, another very, very similar curve, represents your power in watts, which is just your current in amps multiplied by your voltage. So you can see here your power is fluctuating quite a bit, just like you see up above, as I mentioned. So, you get this big spike here, which almost could be a bad data set, but there's, nearly a minute of this large spike. So I kept it in there. I did eliminate some, really just 1 point off, up and down, etc. But this one continued for enough time that I thought it was significant just to leave it in. However, you'll notice here too that the power, as I mentioned, even when it's at 100%, which it reaches, let's say roughly right about here, 100%, 86 minutes, you're still pulling, what, 2 watts power, which is not negligible. It's still a noticeable amount of power that your phone is constantly pulling for whatever reason. So we're going to have a quick look at the Quick Charge 3.0 using Tron Smart 18-watt charger. As I mentioned, it's the same exact thing. Everything's the same. And, your voltage is in blue, current is in orange. So you can see here that the way the Tron Smart one works, it steps current a lot more efficiently, in my opinion, than the stock HTC charger, because you have these smaller intervals here rather than just large periods of flat initially, which is where you usually see the highest temperature increase. I believe the peak temperature for your battery was 107.96, or roughly 108 degrees for the stock charger. I think it's roughly the same, maybe a little cooler here. We'll have to check as we look down below. But as you can see, these data points are changing ever so slightly all the way across, but what's important to look at is the voltage and how it fluctuates. You're getting, 7.78 volts here versus 7.5 before. So you're getting, higher voltage, which should hopefully reduce the heat because you can use a lower current. But you're not using the conventional 9 volts that you would using Quick Charge 2.0. So you can see here, it steps up your current, then it kind of tapers down with your steps up your voltage and it tapers down your current, vice versa. They kind of go back and forth, and then you get your decline here after roughly 55 minutes, which is very idealistic. That's what you see in all these charging methods if you look through all of them, as I'll show you. So what's important to note is look at these 2 spikes in the temperature of the battery, which again, as I mentioned, you're losing a lot of heat as you charge this thing because you're charging it rapidly. So if you look here, you're getting your initial current spike, and then you're going down and go back up a little bit, but it doesn't raise that much. As this declines, they kind of follow each other, but not necessarily the whole time, and you get this kind of odd spike here at the end where it goes all the way back up to 87 degrees. But I'd say the peak here is 107.6. It's ever so slightly cooler, but if you look at the way this temperature curve is shaped versus the previous one, it looks like it tapers off a lot sooner and gets hot, quickly, just like this one does, in 2 small peaks, and it tapers off and it gets there a lot faster, which is good because you want your battery to stay cooler so it charges more efficiently, it charges faster when the battery is cooler. So we're going to go down, we're going to look at the voltage the same way. It's kind of like almost mimicking it, which is interesting to see because we didn't see that on the initial stock charger Quick Charge 3.0 test. And as you can see here, when your battery hits 100%, as I mentioned, at roughly 90 minutes, 85 minutes, you're still, have your voltage running here, and it's not dropping back down to 5 volts like it would because you're still pulling current, which I'll show you down below, or you can see up above, as I mentioned, because the battery reaches 100% here, you're still pulling current. It is negligible. It does drop down a little bit, but you're still above 0 this whole time. So you're pulling 0.03 amps, which is a lot less than it was before, but what's important to note is that it's still pulling current, for what, almost an hour afterwards. Now, as I mentioned, the battery millivolts and the way it fluctuates isn't always ideal like you saw on the stock charger. So you can see here it's literally jumping up and down from 3950 millivolts all the way up to 4350. I'm not sure why it oscillates like this and goes up and down kind of for no reason, kind of erratically almost. But it's interesting to see how the behavior of the battery changes over different chargers. And again, you can see the power curve, of course, mimics as I mentioned before, but it's still pulling, you know, a decent amount of power at the end, a lot less than the other method around the same time. If we look here, I guess it's a little closer at 2 watts, but it's still pulling power all of that time after until you hit, what is this point, roughly 132 minutes, which is, let's say this is 85 minutes, you're looking at, a good 50 minutes afterwards, you're still pulling a sizable amount of power into the battery for whatever reason when the phone is registering 100% charge. Lastly, we're going to have a look at the Quick Charge 2.0 test. And as you can see here, the voltages change a lot more in a sense, but also it just depends on the circuitry in the charger itself, which tries to keep it stable at 9 volts. As you can see here, the current obviously tries to mimic the voltage and tries to keep it consistent throughout the charge. So we're going to go straight down to this guy here, which will show you your battery temperature. And, this curve is not as smooth as the one you saw in the Quick Charge 3.0, but you do get kind of a nice even taper here, and it looks like the peak point is still roughly around the same, but it will step up and down a lot more and still taper off faster in a sense compared to the original Quick Charge 3.0, but not necessarily to the other third-party Quick Charge 3.0 charger from Transmart. So what I want to show you here is the voltages. It's sitting around 9 volts, where on Quick Charge 3.0 you'd have it jump between 4.5 to 7.8 back and forth because it can go up and down in 200 millivolt increments. Here, Quick Charge 2.0 is supposed to be 9 volts, 5 volts, 12 volts, 20 volts, etc. But in reality, you're seeing anywhere from 9.02 to 8.9 back and forth all the way through. And it doesn't really, I don't think it's really trying to fluctuate. I think it's trying to keep it stable because it's not meant to change beyond 9 volts. But as you can see here, there are definitely changes in the voltage as it goes across. And as these voltages change, your battery temperature is not really mimicking it at all like we saw earlier, but it does obviously reach that decline where it tries to go down, but it doesn't go down to 5 volts ever. It just kind of tapers down to 8.92 for whatever reason. I'm not entirely sure, but ideally it would be at 9 volts the whole time, which I have seen on some wireless chargers for my S7 Edge, not necessarily charging via cable. As you can see here with your battery, you're 100% at 94 minutes. You're still pulling a good amount of current. If we look down here, 94 minutes, you're pulling what looks like 0.17 amps. That's still a sizable amount for whatever reason. Phones just keep pulling current. Not sure why, but they're never technically fully charged because they just keep going and going forever and ever. But a good thing to see is just how this temperature changes over the course of the charge and which one is really more efficient. Again, we can look at your battery millivolts. This one kind of changes and steps up and down like we saw on the other third-party Quick Charge 3.0 charger. Kind of very similar behavior here, but this one steps and not as smoothly as before. But a good thing to see is the battery does cool down. You do get overall relatively a cooler battery. I can show you the averages for which one is actually cooler too at the end. But again, as I mentioned, they're still pulling a sizable amount of power, and I'm not sure why, but it does happen. So if we take all this into account, we look at the average temperatures. I'm going to show you some of these data tables here. So we're going to look at specifically, you don't have to worry about this stuff. This is the S7 Edge only. So here is the average temperature for each 15-minute interval using the 3 methods, and it's compared to my S7 Edge. I didn't add in the stock charger to this table yet, but I will. You can see my op on XDA linked below. So if you look here, during the first 15 minutes, Quick Charge 3.0 does get a lot hotter than Quick Charge 2.0, but that is flipped as you get to the second 15, then you go from the next 15 after that, so 30 minutes and 45 minutes cumulative, and you go on. So Quick Charge 2.0 does look like it's more inefficient compared to Quick Charge 3.0 right now. I can compare this to the stock charger and see if that is really true the case the whole time. I'm not sure. But, obviously Quick Charge 3.0 is more efficient, but it's not necessarily faster because Qualcomm said, hey, you're going to get roughly, by the graphs they showed when they debuted it, was 12% faster charge, but in reality, you're not seeing any sizable amount of difference. So here you can see, as I mentioned, my S7 Edge, it stays a lot cooler via Quick Charge 2.0 than the HTC 10 does. Never breaks 100 degrees, which is good to note because that means the HTC 10, for whatever reason, is charging a lot more efficiently than the S7 Edge. So this is what I think is key right here, is the amount of milliamp hours you're charging per 15-minute interval. And, I did this to kind of eliminate anything like, oh, well, I started charging the battery at, 20% one time, not really, but, or 5% another time. And this will allow you to essentially just compare apples to apples instead of apples to oranges. So here, during the first 15 minutes, Quick Charge 3.0 beats Quick Charge 2.0 all the way until you hit, 45 minutes. So I only did this for the first hour. And then Quick Charge 2.0 starts to take over. So it looks like if you want a faster charge, just a quick time, like let's say a half hour, Quick Charge 3.0 will give that to you. But overall, over the course of the full charge, it looks like Quick Charge 2.0 will be faster. So if we look at, I don't know if I put the final times in here. Yeah, here I did. So the starting percentage, did I remove that table? No, I did not. The starting percentage for Quick Charge 3.0 was 15.8 for 2.0. So if you look here, your end time was 85 minutes versus 93 minutes, and that's a 7% difference in battery. You're only looking at 7 minutes, so 1 minute per percent. Not really ideal, but it's just a quick way to look at it. However, Quick Charge 2.0 is nearly the same speed as Quick Charge 3.0 overall. It's just that Quick Charge 3.0 can be a little faster initially, but that's not always the case, and that's also at the cost of a hotter battery. So in reality, which is really better, it's up to you to decide. I prefer using Quick Charge 2.0 because it keeps things more stable, personally. Although Quick Charge 3.0 might be better to use if your phone is already warm, but if you're just gonna, quickly charge and it's average temperature, let's say, I'd rather use Quick Charge 2.0 personally because my phone won't get as hot as it would using Quick Charge 3.0. But Quick Charge 3.0's benefit is that you can charge your phone more efficiently when it's already warm because it can adjust the voltage dynamically along with the current, allowing it to reduce the heat hopefully overall, where Quick Charge 2.0 cannot do that because it's only supposed to be at 9 volts and 5 volts. So I hope this kind of helps explain what's going on, in the op in general. I know there's a lot going on here with all these data sets and a lot to look at, but if you guys have any questions, comments, please feel free to drop me a comment on XDA or down below in the video. I hope you guys enjoy watching this. I will follow up with S7 Edge and kind of what I use to test this.